Welcome to the Phenomenological Alliance channel. In this video, we will mention the basic questions of intuition as the crucial aspect of the phenomenological method of cognition.
Towards the end of the 19th and the beginning of the 20th century, there was a strengthening of the conviction that motion is always relative. This stance influenced the interpretation of the nature of the forces that occur in motion. The centrifugal force, that we perceive as an outward tension when rotating a heavy body around a center, is not related to acceleration, because the acceleration vector is directed toward the center of rotation, not opposite to it. According to Newton's axiom, force causes acceleration. In rotary motion, only centripetal force can really exist. The reactive centrifugal force occurs as a result of the reaction to the centripetal force. It is a consequence of the law of action and reaction. Similarly, the Coriolis force is an example of a force without acceleration. This force causes riverbanks in the northern hemisphere to be steeper on the right than on the left side. The Coriolis force occurs in rotational motion and bends the path of objects. Due to this force, it is not possible to catch a thrown ball on a merry-go-round, as the trajectory of the ball is curved. However, outside the rotating system, observers can see that the trajectory of the ball remains rectilinear. Force results from acceleration, and rectilinear motion only involves rectilinear acceleration. The only force acting on a thrown ball on a rotating disc is rectilinear. The Coriolis force is a perceptual illusion caused by the observer's vantage point, as individuals on the turntable may not perceive that the whole platform is in motion. For example, when we are on a train that starts braking, the pendulum will move backward, because in our frame of reference, a deceleration occurs and therefore the experience of force. However, an observer outside the train can notice that the pendulum remains stationary relative to an external reference point. The pendulum starts moving backward, because the inertia of the pendulum opposes the change of state of motion. Forces that do not cause acceleration are considered fictitious. They are only reactions to an objective physical force.
Newtonian mechanics postulates that in circular motion, there is only centripetal acceleration directed toward the center of rotation. Inertial forces, such as centrifugal force, which do not produce acceleration, are declared a kind of subjective experience. Hence, in the gravitational model of planetary motion, a paradox arises, often overlooked in mainstream physics. Calculations of orbits that exclude fictitious forces indicate the instability of the solar system. The sun's gravitational pull on the moon is twice as strong as the Earth's gravitational pull, prompting the question of why the moon's orbit remains stable. To maintain the conviction that centrifugal force is fictitious, astronomers seek to explain the stability of planetary orbits through the concept of tidal locking, despite the fact that the gravity model faces inconsistencies in explaining tidal phenomena. To accurately calculate the stable trajectories of forces declared fictitious in axioms of the gravity model must also be incorporated in the calculations. The gravitational model is based on the heliocentric picture of the world, also known today as the inertial reference frame, with the axiom that the centrifugal force acting on the planet doesn't exist. Yet, for the practical calculation of the planetary position, the model must leave the heliocentric position of view and accept the rotating geocentric one, or as it's said today, the non-inertial reference frame. The calculation of the stable orbits must also include fictitious forces because they are real forces that occur during the restoration of balance. The concept of inertial and non-inertial frames of reference presumes that we must have a point of view from which we can observe changes in speed, that is, acceleration. And yet, the forces of balance restoration are not the result of the point of view that we perceive with the sense of sight. Instead, they are the outcome of imbalance, which we perceive with the sense of balance. Fictitious forces can be considered fictitious only when perceived through the sense of sight. Without this insight, the centrifugal force is deemed fictitious, despite our direct sensory experience of balance and pressure and our natural intuitive understanding of outward tension.
Intuition is a key concept of phenomenological methodology. However, in contemporary usage, the term intuition is often associated with beliefs guided by inner feelings. The intuition discussed here, however, has nothing to do with inner feelings. Instead, it involves statements whose truthfulness is inherent in the statements themselves. For example, the laws of adding natural numbers are learned intuitively. With the insight that 1 + 1 is 2 and 2 + 1 is 3, we intuitively grasp the sequence. 3 + 1 is 4, 4 + 1 is 5, and so on. But if our intuition is impaired, as in the developmental disorder called dyscalculia, we struggle to intuitively experience the laws of natural numbers and learn addition. The phenomenological insights strengthen the intuitive techniques of cognition because they are based on the confidence that truth is revealed through accurate perception and judgments grounded in common sense. Consequently, phenomenological perspectives occasionally stand in opposition to modern physics, where counterintuitive concepts are frequently justified.